A tunnel is known as an artificial constructed underground passage to bypass any obstacles safely without disturbing the overburden. Or it is also known as an artificial underground passage, especially one built through a hill or under a building, road, or even a river. There are various types of tunnels that could be found. Some tunnels depends on its purposes, types of material used, and followed by the position or alignment of the tunnel. Some tunnels are constructed purely for carrying water for consumption, hydroelectric or sewer purposes. A tunnel can also be carrying services such as for the telecommunication cables. A tunnel may be a path for the pedestrians or cyclists, general road traffic, motor vehicles, rail traffic, or others. For instance, there are a highway tunnel, railway tunnel, pedestrian tunnel, and followed by the subway tunnel. There are some common types of challenges that the construction team might be facing during the tunneling process. First and foremost is the groundwater and water flow. The presence and movement of water can obviously influence the ground behavior. A flowing water might carry materials into newly excavated openings, causing general instability in the mass of rock. On the other hand, it can change the physical property of the ground, which leads to unpredictable consequences. Next is the ground behavior. The rocks or soil will be behaving differently than expected is one of the common problems during the tunnel construction. The nature composition of the ground has implications of how the construction of tunnel should be done, such as with hand mining, drill and blast, with tunnel boring machines, and etc. Add to note that the behavior of the ground can be affected by the presence of water. Then, it is the rock face fallout. It refers to the rocks that falls from the construction phase as a result of weakening the ground and also the supports conditions. There are studies that shows where most accidents occur during the rock fallen when the workers are approaching the tunnel. Last but not least is the existing conditions, where it means that the existing conditions of the construction site are often being sensitive to the construction process. The responsible parties, such as the engineers, should be aware about the surface and underground structures, followed by the hazardous materials that contains in the ground. Be aware that the workers and materials could be exposed to gases which is trapped underground, where the gases might be toxic that can affect the process of the tunnel construction. Then now, we will proceed with the types of the tunnel constructions. There are various types of the method for tunnel constructions. For instance, there are the cut and cover method, bored tunnel method, vertical shaft method, pipe jacking, box jacking, and also the underwater tunneling. All these methods are acceptable in order to make different purpose of the tunnel. The choice of method is determined by several factors such as the geology, cost, and potential disruption of other activities. Different methods may be used on individual tunnels that are part of the same larger project. However, in this video, we will only be explaining some of the methods used for the tunneling constructions. Firstly, it is the cut and cover method. This method is the earliest tunneling method. It was one of the most disruptive processes that a city has to endure. It requires a large stretch of streets above to close for an extended period, creating congestions. There are two ways of cuttings, which are the bottom-up method, which a tunnel is excavated under the surface using ground support, and the top-down method is which the side support walls are constructed first by slurry walling method. It was used to construct the London Metropolitan Line, the world's first underground railway route. Bored tunnel. A tunnel boring machine, or even known as a TBM, is a modern technology for constructing tunnels these days. Tunnel boring machines are used to make the tunneling process much easier. By using the TBM, quicker process of constructing and one of the best method to construct a tunnel beneath a heavy traffic area. The machine can be used in few types of ground such as the hard ground or even the soft ground, depending on its specific types and conditions. On the other hand, the tunnel boring machine can also work in the difficult conditions such as below the water table. A pressurized compartment at the front end is provided for the TBM to work below the water table conditions. Take note that any of the workers should not enter the compartment unless any repairing work is needed. Despite of its advantages, the tunnel boring machines also have its own disadvantages where the huge size of the machine itself is making the transportation of the machine is a bit hard. Also followed by the next disadvantages is that if any damages affect the machine, it could hold the process of the construction into weeks or even months depending on its conditions. Some examples of the tunnels that were made with the TBM itself is our Smart Tunnel in Kuala Lumpur, MRT Klang Valley, and many. The last method for the tunnel construction that we will be explaining in this video is the pipe jacking method. The pipe jacking method is used to construct tunnels under an existing structures such as the roadways, railways, and others. In this method, it is specially made pipes that are driven into the underground using a hydraulic jacks with a maximum size of 3.2 meter diameter is allowed for the tunnels.
As we can see, the objective of this Smart Tunnel Kuala Lumpur is to solve the problem of flash floods in Kuala Lumpur and also to reduce traffic jams along Jalan Sungai Besi and Lok Yew flyover at Pudu during rush hour. In 2011, the Smart Tunnel received the UN Habitat Scroll of Honor Award for its innovative and unique management of stormwater and peak hour traffic. It begins at Kampung Berembang Lake near Klang River at Ampang and ends at Taman Desa Lake near Kerayong River at Salak South. The project is led by the government including Malaysian Highway Authority and the Department of Irrigation and Drainage Malaysia, and also a company joint venture pact between Gamuda Berhad and Malaysia Mining Corporation Berhad. For the benefit of Smart Tunnel, this project was incepted by the project proponent, namely MMC Corp Berhad Gamuda Berhad Joint Venture, primarily to mitigate the recurring floods in the city of Kuala Lumpur, the financial, business and commercial hub of Malaysia. However, at the design stage of SMART, the dual-purpose concept was born from the ingenuity of the project proponents, and the motorway tunnel was integrated into the system to relieve traffic congestion at the main southern gateway to the city center. The safety and health components that can be found in the Smart Tunnel is ventilation or escape shafts at 1 km intervals throughout the tunnel. This will constantly renew the air and maintain the air quality within the motorway section of the tunnel. To protect the ventilation system during flooding, the system consists of a series of shafts, each containing an exhaust and fresh air injector. This enables the fans to be located outside the tunnel, creating a longitudinal flow between shafts that allows the air in the tunnel to be continuously renewed and enables the extraction of exhaust, fumes or smoke in the event of a fire. The tunnel was constructed primarily to mitigate the flooding problem in the city. However, as the incidences of major storms in a year are limited, As an additional function, it is able to provide traffic relief on the southern gateway to the city center. This innovative and unique design poses a very challenging task, especially during the operation of the tunnel. Therefore, these are the 4 different modes of Smart Tunnel Kuala Lumpur. For the first mode, it functions as when the weather is fair with little or no rain, and also when the traffic is allowed to pass through the tunnel. For mode 2, it usually refers to mild storm. The tunnel is activated to semi-open status by allowing diversion of water flow through the lowest channel of the road tunnel section. Therefore, the excess flood water will be diverted to the smart storages, and only the lower drains of tunnel will be used to convey flood flow to the Desa Attenuation Pond. And the road tunnel will still be open to traffic. Mode 3 activates when it is on major storm. The tunnel is activated to fully open status. Automated watertight gates are open to allow flood water to pass through, and the motorway is closed to traffic. Other than that, traffic will be evacuated from the road tunnel. This normally takes about 1 hour. Only 10 meter cubes is allowed to flow downstream. If heavy rainstorm stops early or due to some specific circumstances, then the traffic tunnel will not be flooded. The road tunnel will be reopened to traffic within 2 to 8 hours after closure. Last but not least is the 4th operational mode. It activates if heavy rainstorm prolongs, usually will be confirmed 1 or 2 hours of mode 3 is declared. Road tunnel will be used for passage of flood after traffic evacuation completed. Only 10 meter cubes is allowed to flow downstream. The road tunnel will be reopened within 4 days of closure.
Assalamualaikum and hello to everyone. My name is Afiq Nazran bin Husari. So today I want to talk about a maintenance program in the tunnel. An effective maintenance program helps to reduce costs, decrease the number of tunnel closure, increase public safety, and ensuring adequate level of services. There is 2 types of maintenance that being used, which is planned maintenance and corrective maintenance. The example of planned maintenance is removing debris from the tunnel. Debris present a number of safety concerns, and debris should be removed from the tunnel on a regular basis, since it could be obstruct vision, damage the vehicle, or present a fire or safety hazard. Another example of planned maintenance is tunnel cleaning. Tunnel should be washed when the interior becomes dull with dirt and dust. Washing is also recommended to make the inspection work become easier, and the washing process consists of spraying the tunnel with water and detergent, scrubbing the surface with rotating brushes, and rinsing off the soap and grime using water jets. Next point is drainage inlet and pipes. The drain inlet should be cleaned from any obstacle or debris to prevent from clogging. The last example of planned maintenance is for pavement marking and sign. Pavement marking and sign should be cleaned when it's become dark. This is important to the driver that should be able to see or read the sign and the marking clearly in order to prevent from any incident. Next, we move to the corrective maintenance for tunnel. Corrective maintenance activities are used in response to events that are more difficult to predict, such as impact damage, concrete spalling, equipment failure, and gapping potholes. This method is also appropriate for the repair or replacement of non-critical items that have minimal impact on tunnel safety and the required service levels. If the impact is potentially significant, appropriate contingency plans should be developed by minimize the adverse effect. The first example of the corrective maintenance is damage to tunnel. Among other things, tunnel can be damaged by vehicle collision, fires, explosion, flood, earthquake, rock slide, and landslide. After one of these incidents, a damage inspection should be conducted in accordance with the guideline provided. Next is a concrete detachment. Concrete can loosen and detach because of faulty placement techniques, corrosion of rebar, damage from excessive heat, impact from vehicle, and deterioration. Some of these processes may occur without warning. When concrete debris is discovered in the roadway portion of the tunnel, it should be cleaned up immediately, and any loose or dangling concrete should be removed using small handheld hammers, pry bars, jackhammers, or other appropriate tools. Last example for the corrective maintenance is pavement repair. Roadway wearing surface are typically comprised of concrete or asphalt material. Sealing cracks and patching potholes are part of roadway maintenance. Extensive subgrade repair may be needed due to freezing, insufficient drainage, or loose or fines in the subgrade. Pavement repair should be not allowed to impact the vertical clearance of the tunnel. Next, I want to talk the planning of the tunnel construction. So before the construction start, the planning on the construction should be planned in detail before the project is carried out. Now, I would like to explain the general planning of tunnel construction to an idea on what method that should be used later on. First thing first, the route selection should be identified, then discovered where the routes will be passed through, whether in water or land. Immersed tunnel should be used if the location is in water. For the boat terminal method, both construction in water and land can be used. However, there are 4 other methods under ball tunneling, such as rock tunneling, soft ground tunneling, difficult ground tunneling, and SEM tunneling. Next, we move to the sustainable consideration of tunnel construction. Tunnel is an extreme and energy-intensive process that can have significant site and cost bearing on a project and community. Traditional tunneling requires the use of massive equipment and machinery and substantial consumption of material and natural resources. The constant need for innovative method and technology keeps the industry moving at a pioneering rate. It is not surprised that the major environmental impacts of the tunneling process include energy consumption, material and resources, and site disturbance. There are some inherent sustainable design practices that occur with tunneling procedures, like the increased life expectancy of tunnel as compared to surface treatment, and even to reduce energy consumption via use of local material delivery, reuse and disposal. However, other than this inherent benefit, not much is done to advance environmental stewardship and lessen the impact of a typical tunneling project. Sustainable design not only saves money and the environment but also promotes a positive community perception for local development. Here are 10 tactics for enhancing the process. Number 1. Excavated water reuse, geothermal renewable energy system, low impact development opportunities, mark reuse, fly ash, incline tunneling, green power, biodiesel, renewable hydropower, and restore habitat. Next, we move to the standard of tunnel construction. There are several guidelines or standards that should be used in tunnel construction in Malaysia. First is CIDB standard quality assessment for roadworks. This guideline can be used during the construction and after the construction finish. Next is the guideline from OSHA in tunnel construction. These guidelines are produced by DOSH and highlight the safety aspect. The last guideline for tunnel construction is from Lembaga Lebuhraya Malaysia. The standard is highlighted about the tunnel design standard for tunnel construction. I think that's all from us. Thank you.